The purpose of this SOP is to provide a detailed protocol on the steps needed to operate a HPLC or UPLC. Additionally, explanation of parameters, modules, and responses will be discussed. The scope. This standard operating procedure will apply to both the manual and automatic HPLCs and UPLCs at Monash University Parkville campus. Definitions. You may want to pause the video to have a read. Procedure. This section describes the modules, parameters, and responses of HPLC. This section also describes the protocol needed to operate a manual, automatic HPLC, and UPLC. Here is a summary flowchart where the most important instructions are collated. This video will teach you how to turn on the HPLC and lab solution software, change solvent lines, purging, creating a method, changing parameters like %B, temperature, and gradient, as well as equilibration, injection of samples, peak integration, data reports, meta files, and data comparisons. There are 7 key modules of a HPLC system. These include the mobile phase or solvent, the degasser, the pump, the injector system, the column, an oven, and finally to the detector. The mobile phase is polar and composed of water and/or organic solvents with other additives. This liquid mixture will carry the sample and push it through the instrument. The mobile phase plays a role in separation, where the higher the affinity of the sample towards the mobile phase, the faster the analyte will travel. Degasser. It aims to remove dissolved gases present in the mobile phase which can interfere with the operation of the pump, column, and detector. The mobile phase is pulled through a semi-permeable membrane, which are held in a vacuum chamber. Gas is then drawn out into the chamber. When the pressure exceeds a preset threshold, a valve opens and a vacuum pump removes the dissolved gases to re-establish the vacuum. Pump. It serves to supply the force necessary to provide a constant flow rate, regardless of the resistance met in the system. It helps to ensure consistent retention times. It also helps to mix the various mobile phase solvents under high pressure. Each pump system consists of 2 piston pumps. Each piston has 2 check valves, which direct the flow in one direction. They also contain an eccentric cam with a string piston attached and a liquid chamber. When the cam is out, piston is pulled and allows the mobile phase to fill the solvent chamber. When the cam rotates in and starts pushing the piston, it allows the mobile phase to leave the pump. The dual pistons allow for continuous flow, as when one piston is pulling the solvent into the pump, the other piston can push solvent out of the pump. The injector will inject our samples under high pressure. Manual HPLCs have a manual injector, which requires us to inject the sample with a needle. In automatic HPLCs, this process is done by the instrument. There are 2 positions an injector pump will operate in. The load position. The injector consists of a stator with 6 ports and rotors that have channels which can connect the flow of different ports. The solvent from the pump enters port 1 and goes to port 3 towards the column for equilibration. The sample is injected through the pore in the rotor, which leads the sample towards port 4, where it enters the sample loop. The sample then enters port 1 and goes to port 6 towards the waste container. By turning the lever to the inject position, the channels of the rotor change such that ports 1, 2, and 3, 4 are connected. The solvent from the pump enters port 1 and goes to port 2, where it pushes the sample in the sample loop towards port 4. From port 4, the sample is pushed to port 3 towards the column. Columns. HPLC columns are packed with spherical silicon gel beads which have non-polar molecules bonded to the surface of these beads. The ligands are responsible for the interactions between sample components in a stationary phase. The higher the affinity for the ligands, the longer the compound is retained. Oven. The oven controls the temperature of the column. Elevated temperatures can improve performance, lower back pressure due to a lower mobile phase viscosity, and reduce analysis time. Detector. On the HPLCs, there are UV vis detectors, which operate by passing visible and UV light through a sample in a flow cell, and then it measures the absorption at a particular wavelength. The amount of light absorbed provides information on the properties of the sample of interest. For the UPLCs, there is a diode array detector, which can detect multiple wavelengths at once, and thus can provide more information than a simple UV vis detector. Here are some parameters of a HPLC, or things that we can change. So starting from the mobile phase, we can change the pH and type, and then for the pumps, we can change the %B, the method, so either isocratic or gradient. If it is gradient, we can change the %B initial, %B final, and the gradient time. For the injector system, we can change the sample type, sample concentration, and injection volume. At the column, we can change the stationary phase, the length, the internal diameter, particle size, and bead type. And at the oven, we can change the temperature, and at the detector, the wavelength. These parameters have been color-coded to represent if they affect the responses chemically or mechanically. When we name data files, we first start off with the unique identifiers, so the group number, injection number, and HPLC number. For each new injection, there will be a new number assigned. Then we list the parameters according to the progression of the mobile phase, the read instrument. So firstly, we talk about the solvent, then the pump, etc. Separate each entry with a dash. Here are some two good examples. For the PDF data files, it will have the same name as a data file, but you should include the timescale at the end. For method file names, will only contain parameters controlled by the machine. For more info on what the parameters are, please refer to the previous section. Responses of a chromatogram. So here on the right-hand y-axis, it is intensity, which corresponds to the absorption of UV light by the compounds in the units milli-AU. On the first right-hand y-axis is back pressure. This is a key side effect that we must be aware of. Too high of a back pressure can destroy the column in HPLC. The second right-hand y-axis is %B. On the x-axis is time in minutes. And here circled in red are responses which can be read on the chromatogram, such as number of peak, retention time, AUC, and width. And circled in green are those that are already calculated, so retention factor, selectivity, HETP, number of plates, and resolution.